Hi grade 9s, welcome to this week's video. This is going to be our first video about circle geometry. So we're going to introduce some concepts that might be a little bit weird, but we're going to kind of ease into it. So as long as you've done the Pythagorean theorem work from last week, this stuff this week should actually be pretty straightforward. All we're really doing is we're going to be using Pythagorean theorem in relation to circles. And I'll show you guys how that will work. It sounds overwhelming, but it's really actually not. So here on this page, I have a circle. That's that round shape there. Hopefully you know that. And then I have a line. So if I take this line and I put it through a circle like this, you can see it intersects at two spots. So it intersects the circle here and it intersects the circle over here. So it cuts through that circle in two places. If I move this line, I can change where it intersects that circle, but it always intersects at 2 points. Like I can move it up here and it's still intersecting 2 points. Something happens though when I move this line and I get to this magical spot right here, and it's only intersecting the circle at 1 point. So it's intersecting right here. So instead of cutting through the circle at 2 places, it's only intersecting at 1. And this is a really important idea here. This line, when it intersects a circle just at 1 point, is called a tangent line. So this now I'm going to call a tangent line, or just a tangent. And then this, where I put the red dot, where that line touches the circle, I call the point of tangency. And I can make a tangent line over here. I can make it over here. That's not really a good tangent line, something more like that. But I'm just going to use it up there kind of at the top left just for this example. So if I draw a dot, it's probably not going to be perfect, but pretty close to the center of my circle, I know, hopefully we remember from grade 8, that if I draw a line from the center of the circle to the outside of the circle, that is a radius. Radius, we also probably defined it as halfway across the center of a circle. The full way across the center is the diameter. If I just go halfway, I'm talking about a radius. So if I take my pen and I draw a radius from the point of tangency to the center of the circle. Radius we usually label as R. There's something kind of neat that happens with that radius. Now if you look at the radius in relation to the tangent line, you might notice that there's something that's happened with the angle that it forms. So this radius, when it goes to the point of tangency, is going to be perpendicular to the tangent line. Perpendicular is just a fancy math way of saying it makes a 90-degree angle. So what we can say is that the tangent to a circle is perpendicular, which means 90-degree angle to the radius, at the point of tangency. So really, all that means is that we get this 90-degree angle right here where the radius and the tangent line meet on the edge of the circle. And if you remember last week, when we were talking about Pythagorean theorem, we used right triangles. So here you can start to see where Pythagorean theorem and our circles are going to work together. So this just summarizes what I just wrote on the other slide. A tangent to a circle is perpendicular, or makes a 90-degree angle, perpendicular to the radius at the point of tangency. And so you can see that in this example that I've put here. So line AB is a tangent line, and you might see that written a couple ways. So we could say the tangent line is AB. You might see it with a line over top, line AB, line segment AB, and that means basically the same thing. Our radius would be OP right there. And then, of course, we have our 90-degree angle, and they've showed that with that little square in the corner. So what I've given you guys here are just some examples of how we can kind of write or represent different parts of this setup. So where I put this weird kind of squished L, that means angle. So this guy here is a symbol that means angle. So I'm asking about angle APO. So all that means is I'm going to go over to point A, draw a line from A to P to O, and I'm going to look at the angle that forms within that line segment. And what do we know? Well, it's 90 degrees. Angle BPO, I go over here to point B, BPO. Well, my tangent line is a straight line, and a straight line is 180 degrees. So if one side of that angle is 90, the other side also has to be 90 degrees. That's all that we need to know for this week. So in this example, they tell us point O is the center of a circle. So that's the center right there. AB is a tangent. So AB here is a tangent. We can imagine that it continues on like this in a straight line, if that helps. In angle OAB, or sorry, in triangle OAB, so that's just the triangle that's made here in the circle, AOB equals 63 degrees. So AOB, this angle here is 63 degrees. Okay, and they labeled it for us in the picture. Determine the measure of, I should probably say, angle OBA. So angle OBA is this angle here. We're trying to find the measure of that angle. Well, hopefully we remember the interior angles of a triangle add to 180 degrees. If you didn't remember that, put it in your brain. The interior angles, the angles inside a triangle, always add to 180 degrees. Well, I know that this guy here is 63. I'm trying to find this guy up here. I need to know what angle this is. Well, remember, our tangent line makes a 90-degree angle with the radius. So this angle here is 90 degrees. So that means I can go 180 minus 90 gives me 90, minus 63 gives me, let me do a little bit of math here, 27 degrees. So angle OBA equals 27 degrees. And I can double check that. 27 plus 63 plus 90 should equal 180. Next example, point O is the center, again, just like last time. CD is a tangent to the circle. So line CD here, this is our tangent. Length CD is 15 centimeters, OD is 20 centimeters, and they labeled those for us. Determine the length of the radius, OC. So we're trying to find this here. So I'm just going to go in and I'm going to label that either question mark or X. I'm going to use X. Give the answer to the nearest tenth. Okay. Well, the first thing that I want to do when I see an example like this, I want to go in and draw my 90-degree angle. In this example, that would be right there. Remember our tangent line. This guy here is going to meet at 90 degrees to our radius. So we're trying to find our radius. We have a right triangle. We know two sides. We need to use Pythagorean theorem. So I'm just going to sketch that triangle over here, just a little bit bigger. It's not going to be perfect, so sorry about that. There's our 90 degrees. Here's 20. Here's 15. Here's X. Now remember, opposite our right angle is our hypotenuse, so I'm going to label that side C. I'm going to label 15A, and I'm going to label X B. Remember, A and B don't matter. And then our Pythagorean theorem, a squared plus b squared equals c squared. Well, I am looking for b. So I'm going to do a little bit of rearranging. B squared equals c squared minus a squared. But then I don't want just b, I don't want b squared, I want b. So I need to square root both sides to get b on its own. So b equals the square root of c squared minus a squared. And now I just need to go in and plug in my numbers. So b equals the square root of c squared, which is 20 squared, minus a, 15 squared. I'm just going to plug those into my calculator because those are some bigger numbers. So 20 squared minus 15 squared. I am getting the square root of 175. Please don't put 175 as your final answer. Remember, you need to take the square root of that. So I plug in that. I get 13.2287 something, something, something. They asked me to round to the nearest tenth. So that gives me my final answer of 13.2 centimeters. That would be my final answer. Please don't forget your units. And our last example, an airplane, A, so this is my airplane here at this point. Maybe I'll just draw a little airplane in there so that I know what's going on. I don't know what an airplane looks like. It's been so long. Something like that. Cruising at an altitude of 9,000 meters. A cross-section of Earth is a circle. So this is our version of Earth. They've given us Earth's radius. Radius approximately 6,400 kilometers. So there's 6,400 kilometers. And then the airplane is 9,000 meters above that. A passenger wonders how far she is from point H on the horizon. So there's point H. Sounds like we're trying to find this distance here. Calculate the distance to the nearest kilometer. So we're trying to find, I'm going to call this side X. And I guess I'll just color it blue. But I don't see a triangle. Well, please don't try to do this without a triangle and without Pythagorean theorem. Don't guess. Make a triangle. Well, to turn our two lines here into a triangle, we would need to connect the dots and draw another side there. And what is that side? Well, it goes from the center of Earth to the outside. It is a radius. Do we know what the radius of Earth is? Yes, because they told us over here. It's 6,400 kilometers. So I'm going to go in and I'm going to label that. I think I can zoom in. I think we're done with the text. So there's 6,400 kilometers. Perfect. I know two sides. I can find my missing side. But before I can do that, take a look here at this side that I'm going to just color green. It's not just 6,400 kilometers. It's 6,400 kilometers plus 9,000 meters. By now, we should know that there are 1,000 meters in 1 kilometer. So we should be able to really quickly convert 9,000 meters into 9 kilometers. So that means that this whole side here is 9 kilometers plus 6,409 kilometers. So altogether, 6,409 kilometers. I think I misspoke there. I think I said 6,409 when I meant to say 6,400. So I add these two together. I get 6,409 kilometers. Now I know two sides. I can find my missing side. So I'm just going to sketch out that triangle over here. So there's X. Again, not perfect, but that's okay. And be really careful. Make sure that our right angle is going in at the right spot. So I'm going to label this side C. I'm going to label this side A and this side B. Remember, across from the 90-degree angle. I'm going to skip ahead to my final version of my Pythagorean theorem. So B equals the square root of C squared minus A squared. If you can't do that easily by now, you need to let me know. Please send me an email. So B equals the square root of C squared, which is 6,409 9 minus 6,400 squared. Make sure your numbers go in the right spot. If you accidentally switch around, you'll end up with a negative number here, which won't work. So make sure you have those numbers in the right order. I'm just going to punch that into my calculator. Ooh, that's a really big number. So I end up with b equals the square root of 115,281. So b ends up equaling 339.530 something something. If I go back up, it asked us to find the answer to the nearest kilometer this time. So this time my answer would be, the 5 would round the 9 up, so it would end up being 340 kilometers as our final answer. That's it for this week. There's lots of practice for you to do, so please work through that. The answer key is attached. I'll post a video tomorrow on Tuesday of myself going through those practice problems. If you have any issues, please send me an email. I'll either try to respond with an answer, or we can figure out a time for a Google Meet so that I can show you on my iPad here, just like I've been making these notes. So again, please make sure you're doing the practice. The assignment for this week will be posted on Thursday. Let me know if you have any issues. Thank you.